In this video, we evaluate this indefinite integral of x to the third minus x all divided by x to the 6 minus 1. So let's start off by breaking down the denominator to see what the denominator really is. So the denominator is x to the 6 minus 1, right? So we are going to do a polynomial long division here. So x to the 6 minus 1 has two factors. So if we just look at it, we can see that 1 is a factor, x is equals to 1 is a factor. So that implies that x minus 1 is a factor of the polynomial x to the 6 minus 1. In the same way, x is equals to negative 1 is also a factor. So that implies that x plus 1 is also a factor of this polynomial. So that implies that x minus 1 multiplied by x plus 1, which is the difference of two squares, that is x squared minus 1. X squared minus 1 is a factor of this polynomial x to the 6 minus 1. So what we are going to do here is we are now going to do a polynomial long division to see the other factor of this polynomial. So I am going to divide the polynomial, and the polynomial x to the 6 minus 1 can also be written as x to the 6 plus 0x raised to the power 4 plus 0x squared plus 1. So I can also write it this way, minus 1, I'm sorry, minus 1. So I am going to divide this polynomial by the factor x squared minus 1, because x squared minus 1 is a factor of this polynomial. So I want to have an idea of what the other factor looks like. So x raised to the power 6 divided by x squared is going to be x raised to the power 4. Then you multiply, you have x raised to the power 6 minus x raised to the power 4. Then you subtract. Once you subtract, the x raised to the power 6 term will go away. Then you have 0x raised to the power 4 minus x raised to the power 4. That gives you x raised to the power 4. Then you bring these guys down here. And then you divide again, x raised to the power 4 divided by x squared. That gives you x squared. Then you multiply, that gives you x raised to the power 4 plus minus x squared. Then you subtract again. Once you subtract, the x raised to the power 4 terms will go, and then you have 0x squared minus x squared. That gives you positive x squared minus 1. When you divide for the last time, that is going to give you plus 1. Then you multiply, you have x squared minus 1. And when you subtract for the last time, see that that equals to 0, right? So that implies that if you are dividing x raised to the power 6 minus 1 by its factor, x squared minus 1, that is going to give you x raised to the power 4 plus x squared plus 1. This is the answer as a result of the polynomial long division. That is the quotient, right? So it implies that x raised to the power 6 minus 1 can be written as x raised to the power 4 plus x squared plus 1 multiplied by x squared minus 1. So in place of this one in the denominator, I'm just going to replace that with this one, right? So I is going to be the integral of the numerator can be expressed as x into x squared minus 1, just factorizing x out. And the denominator now can be written like this. So that is x squared minus 1 multiplied by x raised to the power 4 plus x squared plus 1 dx. Cool. Now let's deal with this one. So I is going to be the integral. This will cancel that. Then you have x all over x raised to the power 4 plus x squared plus 1 dx. And we can express this one as the integral of x all over x raised to the power 4. I'm going to write that one as x squared plus x squared plus 1 dx. And now let's do a u sub. We can let u to be equal to x squared. So that implies that du is 2x dx. Can divide both sides by 2. That implies that 1/2 du is going to be x dx. So in place of x dx, I'm going to replace that with 1/2 du, right? So we can take our integral from the x world into the u world. So I is going to be x dx, that is going to be 1/2 du, like this, all over x squared. X squared here is u by squared, and that is this one, plus x squared is u plus 1. So this is how our integral can be split. 1/2 the integral of 1 all over u squared plus u plus 1 du. And this one, I'm going to complete the squares of the denominator. So I is going to be the integral 1/2, the integral of 1 all over. This one can be written as u plus 1/2 all squared plus 3 over 4 du. This is how this one can also be written. So let's look at it. U plus 1/2 squared. When you're foiling this, that is going to be u squared. Then this times that times 2, that is going to be plus u plus 1/2 squared is going to be 1/4. So we have u squared plus u plus 1/4. We are only left with 3 over 4 in order to get 1 here. So that is why we added 3 over 4 to the the denominator, right? So this is how the denominator can be expressed, that is completing the squares. And now we can realize that this one is can compare this one to the arctan integral. The arctan integral of 1 all over x plus a all squared plus b squared. This one can be um, solved by this 1 over b, the tan inverse of x plus a all over b, right, plus the constant of integration. So that is the arctan integral. So I here is going to be 1/2 the integral of 1 all over u plus 1/2 all squared plus 3 over 4 can be written as the square root of 3 over 2 all squared du. And now we can compare this one to the arctan integral. So now let's solve this integral using this one. So I is going to be 1/2, then 1 all over b. B here is the square root of 3 over 2, like this. Then the arctan of x plus a. Our x plus a here is u plus 1/2 all over b. B here is the square root of 3 over 2 plus the constant of integration. Now let's rearrange this one. This will cancel that, and allow it 1 all over the square root of 3. The tan inverse of this is 2 times u plus 1/2 all over the square root of 3 plus the constant of integration. So I is going to be 1 over the square root of 3 tan inverse of multiplying inside is going to give you 2u plus 1 all over the square root of 3 plus the constant of integration. We are not done. We have to move back into the x world. So we know that u was equal to x squared. So just replace u with x squared. So I is going to be 1 over the square root of 3 tan inverse of 2x squared plus 1 all over the square root of 3 plus the constant of integration. Therefore, if we integrate, which is what is the integral? So the integral is x to the third minus x all over x raised to the power 6 minus 1 dx. This one evaluates to 1 all over the square root of 3 tan inverse of 2x squared plus 1 all over the square root of 3 plus the constant of integration. So this one is the value of our integral. So that is how I can solve it. If you have an easier way of solving it, leave a comment in the comment section and let me know what you think. Anyway, I thank you so much for watching this video. If you find that helpful, give me a thumbs up and subscribe to my channel for more content. I thank you and I'll see you in the next one. Bye bye.